So hello guys, welcome to lecture 7. So today in this video we will be discussing about BJT, or which can also be called as the bipolar junction transistor. So what is a bipolar junction transistor? So let us go by its name. Bipolar means it has two poles. Junction means there are p-n junctions involved, and transistor means transfer of resistance. So there is a BJT is a device which has two p-n junctions and two poles. Now we are going to realize a transistor by making use of two p-n junctions. So this is a p-n junction, that is p-type semiconductor fabricated with a n-type semiconductor. Now to make another p-n junction, we do not have to again put another p and another n. Just we have to keep in mind that we need two junctions. So this is one junction, so we need another junction. So either we can put a p-type semiconductor here, or we can put a n-type semiconductor here. So if we put a p-type semiconductor here, it becomes a PNP transistor. And if we put a n-type semiconductor here, it becomes a NPN transistor. So now it's clear that BJT is formation of two p-n junctions, and here we have either PNP transistors or NPN transistors. So BJT can be broadly divided into, classified into PNP transistor and NPN transistor. So now let us see how it can be implemented, and now we will discuss its implementation as well as its symbol. So this is a transistor. If there is an arrow mark towards outside, it is a NPN transistor, and if there is an arrow mark inside, it is a PNP transistor. So there are two types of transistors. So which kind of transistors are, where they are used, we will discuss now. Normally, in all types of analog electronic circuits and analog circuits in all domains, and in electronics, in amplifiers and any devices, NPN transistor is preferred. Why? There can be a question asked in your exams that what is the reason of using NPN transistor, and you will have a reason, and again you have to explain that why. So the first reason, that is NPN transistor, it has high speed operation compared to PNP. In NPN transistor, the speed of the response is very high as compared to PNP. Now the question is how and why. Now considering NPN transistor and PNP transistor, here the N-type semiconductor is 2 times than the P-type, which happens in reverse in this case. P-type semiconductor. So here in PNP transistor, the P-type, the concentration of P-type is twice that of N-type. So what happens? It is a PNP transistor and this is a NPN transistor. So in NPN transistor, the concentration of electrons, these are the electrons are present in N-type semiconductor. Here also N-type semiconductor. And in P-type semiconductor, there are holes present. So, as you could see, in PNP transistor, there are more holes than electrons, and in NPN transistor, there are more electrons than holes. And by concept, we know that the mobility of electrons are more than that of holes. So, as more electron concentration are present in NPN transistor, therefore the NPN transistor are high in speed in operation. But in case of PNP transistor, there are more holes present than that of electrons, where electrons having the higher mobility as compared to holes, and there are more holes in PNP transistor, the concentrations of hole is more, therefore this is slower. The PNP transistor is slower as compared to NPN transistor, but still PNP transistors are used in other applications where this kind of property is required, and that we'll discuss when we will cover that part later. Now, holding the NPN transistor, we will move on to the bipolar junction transistor configurations. So now, discussing about the configurations. So there are three types of configuration. The first one is common base configuration. Second one is common emitter configuration, and the third one is common collector. So now you are having a question in mind: what is base, what is emitter, what is collector? So as I showed you the diagram of the BJT, bipolar junction transistor, there are three terminals present here. This is the first terminal, this is the second terminal, and this is the third terminal. This one is called base. This one is called collector. And this one is called emitter. Why these names are given so? So, in this BJT, the purpose of collector is to bring the current. Purpose of emitter is to emit the current out. And the purpose of this base is to control this incoming and outgoing of current. Let us explain this in a very easy manner. Now guys, here you would be seeing a wash machine. Now here, this part is the emitter because it emits water. This part is the collector because from the pipe or the water pipe from the tank, the collector is present here. It collects water, and this one emits water, and this part is the base because it controls. So when we loosen the base, the emitter, the water flows from the emitter. Same as in the BJT, the current flows in this manner. When the base current is altered, the amount of current from the emitter is varied. So this was a typical example to explain the performance of BJT. So guys, here from the tap experiment, as we saw, when the base is varied, the collector current and the emitter current were varied, where the base was the cap, the knot, and the emitter was the pipe mouth or the mouth of the tap, and collector is the pipe connecting the tank or the water tank. If this base is completely closed, whatever amount of water might be present in the tank, that will not affect or that will not flow through this connection. Now, moving on to the real diode equation and how does this represent this tap experiment. Now, the current coming from through the base is called the base current or IB, and the current coming from the collector is called the collector current IC, and the current going through the emitter, the last current, is called the IE, emitter current. And the property of a transistor is defined by its beta value, where this beta value decides the base current, and the entire principle or the entire relation between the IC, IB and IE. From the general transistor equation, it is given that IE equals to IC plus IB, where it states that the emitter current is equal to the collector current, the sum of the collector current and the base current. There is another equation which says that IC equals to beta into IB, where the collector current is dependent upon the IB current and also directly proportional to the beta value. So these equations are used. These two are the only equations. By using these two equations, we can solve any type of configuration circuits in where the transistor or BJT is being used. Now moving on to the first configuration, that is the common base configuration. In common base configuration, the transistor, the base is connected to the emitter, emitter as well as the collector. So this configuration is called common base configuration. So this is the IB, this is IE, and this is IC. Then common collector configuration. So this is the collector. So the collector is connected to the base as well as the collector is connected to the emitter. So this is the base current IB, the collector current IC, and the emitter current IE. So this is the common collector configuration. Now moving on to common emitter configuration. In common emitter configuration, the emitter is connected to the base as well as the emitter is connected to the collector. This is the common emitter configuration. So here it is the IB or the beta current, the base current, it is the IC, and this is the IE. So there are three types of configuration present in a BJT, that is the common base configuration, common collector configuration, and common emitter configuration. Now, these three configurations are complete. Now, these three configurations are complete. But do you think the circuit is complete? No, because a circuit without a voltage source is never complete. So, how to put the voltage source in these three circuits? So, here the voltage source will be put at the junction of any two or both of the connections. Like here is the collector, here is the base. So there should be a voltage source present here. Now here is a base and there is a collector. So there will be another voltage source present here. In the same way, here also there will be a voltage source present between the base and emitter and the collector and emitter. And here there will be a voltage source present between the collector and the base, and another voltage source will be present in the collector and the emitter. So, now, how to name these voltage sources? So these voltage sources will be named as per their connection. So this voltage source is connected from the collector to the base C and B. Therefore, this will be named as BCB. And here it is connected from base to emitter. So this will be named VBE. Here in common emitter configuration, it is connected with the base and emitter. So this will be named VBE, and this one connected from the collector to the emitter. So this will be VCE. Here in common collector format, it is connected from BC to the collector from the collector to the base. Therefore, it will be VCB, and here it will be VCE. So all the voltage sources are connected. Now, from this voltage source, these types of current are driven, which will be following the two formulas, that is which we discussed now. IE equals to IC plus IB and IC equals to beta I. Now, using these two formula and these three configuration, you could be able to solve all the kind of BJT circuit problems. So guys, today in this lecture 7, we discussed about the concepts of bipolar junction transistor and how it is constructed, the NPN and the PNP transistors. Then we discussed about the emitter, base, collector, the three terminals of this BJT. Then we discussed about the different configurations of the bipolar junction transistor, that is the common emitter, common base and the common collector. Then we discussed the current equations of the BJT and how the voltage sources are placed in all these three configurations. In the next class, we will be discussing some circuit examples and we will be also doing some circuit problems regarding the BJT, involvement of the BJT. Then, so if you find this video informative, please hit the like button, and if you have any doubt, write to us in the comment section and subscribe this channel and share this channel as much as you can. So stay tuned. Goodbye.